Okay, wonderful. So welcome to the Jaeger project introduction. My name is Juraci Paixão Kröhling. I'm a software engineer at Red Hat. I work on the Kiali project on the distributed tracing team. So I work on the distributed tracing components. And I'm a maintainer on the Jaeger project and a collaborator on open tracing. And as a maintainer of Jaeger, I'm here talking to you today. So this is a double session. So we have the project introduction, and right after that, we have the deep dive. The plan was to have someone from Uber here delivering as well, but he's got some visa issues, so he could not join us here in Barcelona. So the plan now is then to have like 30 minutes introduction session, plus 5 or 10 minutes of Q&A, and then some 5 minutes of like a small break. So if you are interested only in the intro part, you can skip the second part and attend something else, and as well for other people who know about Jaeger already, but prefer only to watch a deep dive. So we have a 5-minute break between those two blocks, right? And of course, I'll be here, so you can still ask questions after that. And for the second half, we have it very similar, so half an hour for the deep dive, and the remaining of the time then for questions and answers. Whoops. Okay, so it's very hard to talk about Jaeger and not talk about tracing or distributed tracing. So Jaeger is a tracing solution, but what exactly is then distributed tracing? So if you've been to any other tracing talks this week, or perhaps some open telemetry talks, then you've probably seen some introduction to tracing. But for those of you who are still new to tracing, we use that to understand what our application is doing, right? So we have microservices, or we have some distributed system, and we have calls between the services. And we want to visualize individual business transactions as they flow across our infra. So imagine that we have one HTTP request reaching our front-end service, and as part of processing that HTTP request, we make some database calls, and we then go to an external microservice, and that microservice goes to yet another microservice, and so on. And tracing then shows you the picture of that request, that original request, as it flows across all those 3 or more microservices, including database calls that we make in between. Right, so in summary, distributed tracing tells us the story of a request as it flows across all the services. Now, we need tracing, or we use tracing in general to understand problems, right? So to do root cause analysis. So we see that we have a specific, or we have problems with our system across a specific timestamp or time range. And we then filter all the traces or all the requests that affected that service or that machine on that time range. And then we can dig into each one of those traces and understand what happened there. So as you can imagine, this is very useful for network latency, or to visualize if we have unnecessary calls and things like that. And the way it works is actually quite simple, right? Tracing works by propagating context. So when we call from one service, when we go from one service to another, we serialize our context in one place, and we send this context along with the payload to the next service. In HTTP terms, it typically means that we store the context as a HTTP header on the outgoing HTTP request. So if we're on a microservice and we are calling the second one, we just add another HTTP header. On the other side, we deserialize, and whenever we create trace information, he's asking me to ask you to go to the middle of the, because we have people standing there. Yeah. Thank you. Okay, thank you very much. Right, so then how does it work? Then we serialize context on one side, And on the other side, on the second, third, fourth level microservice, we look up the HTTP headers, and if we have a header with the context, we deserialize that. And whenever we create new tracing information, we use that as our starting point. Now, the context here might be a little bit too abstract, but typically it just means an ID, right? So we create an ID at the very first point of touch in our system, and we propagate that ID downstream. So that's basically how it works. But we are not here to talk much about tracing in general, right? We are here to talk about Jaeger. And our final goal here with Jaeger, or with tracing in general, is to have a screen like this. So I'm running now a very quick demo showing you what Jaeger is and how it actually works. And that, yeah. So I have here, or I had here planned to run a demo using Istio, because, you know, Istio. But as you can see here, some things are not working, so I have a backup plan here. So I have 3 microservices. They are built using a new Java framework called Quarkus. So Quarkus is a framework for cloud-native Java applications. I'm not here to talk much about Quarkus, but perhaps I should just say that applications built using Quarkus, they are very small, and they compile to binary, to machine code. So you can just execute them and place them on Docker images. So they're very fast to boot and consume very little memory. So that's key to cloud-native applications, right? So that we can scale very quickly. I have then a second microservice, also built using Quarkus, and a third one. All right. Looks like it's working. And I'm then opening the Jaeger website, and I'm just copying, from Jaeger. We go to the getting started page, which is this one here, and I'm just going to copy the Docker command that we see there into this this terminal here. And I'm not copying the -d because we want to see all the logs. Okay, so Jaeger is running. Our 3 microservices, they are running as well. And I'm then just, can you guys in the back see the code here? Okay, cool. And I'm just then running like 3 HTTP requests to the first service. Now, we don't know this application, and we know pretty much nothing about what it does, but we can use Jaeger to visualize what happened. Right? So I have here 2 traces that I created before, but those are the 3 new requests that we ran. Right? So for each request that we have, we see all the data on one trace. And I think it's now too small for the guys in the back. And now we have here all the individual operations that were executed as part of that business transaction. Right? So that initial HTTP request reached our service as a GET request on /, so HTTP localhost 8080 / as a GET request. So we see that information here. And that then called the submit order operation, and this is something that I manually added to my code, this operation here, so I'm able to do explicit instrumentation for those who know about instrumentation in general. And then we have another automatic span here. So each line here is called a span in tracing, right? And that represents a unit of work. So this is basically Jaeger, right? So we see all the information about the individual requests. We don't only have this view here, the timeline view. We also have the graph view. So we are also able to see what are all the operations that were called as part of this HTTP request in a graph view. We see each service has a color, so we see that there are 3 services here being touched. It's a little bit difficult to read when you have a lot of nodes here. But if you over one of those here, you see more details about that span. We can color them also by time, so we see which spans took most of the time. And this kind of view here is also the base for comparing traces. So if we have one sane trace and if we have one errored trace, we can compare both, or we can compare even more traces and see what are the differences between them. And it uses the diff syntax, so in this case here we don't have any difference, so it's gray, right? But if we had spans only on the A side, not also missing on the B side, it would be red, following the diff colors, and the opposite, meaning B having more spans than A, would be colored in green. And so this is basically Jaeger in the UI part, right? This is the final outcome. So once you have everything working, once you have Jaeger running, in my case here, as a Docker container, once you have your applications instrumented in any way that you can instrument your application, be it manual instrumentation, be it by a framework instrumentation, be it by a service mesh instrumentation that I wish I could show you here. Once you have all those instrumentation code in place, you would be able to see data here on Jaeger. Besides the comparison and search of the traces, we also have a basic graph view or service graph view here. Right? So this is not 100% accurate when you have services which are not traced or not instrumented. So I would not rely on that for architectures that where you're starting to trace things, because you are then missing points here. But it's still very useful if for greenfield applications to see what are the dependencies between those services. Oops. Okay, so this is basically a very high-level overview of what is Jaeger. But so if you are a developer, what is Jaeger for you? Right? So Jaeger, for developers, is basically the Docker image that we just ran when you are developing, when you are debugging issues. So you start the Jaeger backend components as a Docker container. But more importantly, it is the tracer that you plug within your application. So you instrument your application, you use framework instrumentation libraries, and then Jaeger for you becomes only the component, the actual tracer, the thing that actually knows how to record data. Right? So the instrumentation that you use is your description of what should be recorded, what should be measured, and the tracer or the client is the thing that actually knows how to do that. Now, if you don't want to use the Jaeger client or the Jaeger tracer, so Jaeger client and tracer, they are two names for the same thing. But if you decide not to use the Jaeger tracer, you can use OpenCensus or in the future OpenTelemetry and plug an exporter for Jaeger. Right? So you can have the same tracer for your application and just change the exporter if you decide to change to or from Jaeger in the future. Now, if you are an ops person, then Jaeger means something different to you. First, it means the things that you have to deploy and maintain in production, like the whole infra for Jaeger itself. But perhaps more importantly or more useful than that is the tool that you use to do root cause analysis or to visualize what your microservices are doing, basically. So if you detect an issue using some metrics tools or dashboards, you can probably zoom into individual requests, and once you know the time window or the time range where your problems are happening, you can then select all the traces from that period of time and then look into individual traces. So the Jaeger is your tool for that. You can deploy Jaeger on pretty much everywhere, right? So bare metal, you can deploy it. We have binaries for Mac OS, for Windows, and for, of course, Linux. This is KubeCon, so I assume everyone here is running Kubernetes. So you can, of course, run Jaeger on Kubernetes or Kubernetes distributions like OpenShift. Jaeger is actually a build itself following the microservices approach, right? So we have quite a lot of components here. One of them is very separate from the others. This is what we, depending on the situation, we call that the Jaeger client, and depending we call that the Jaeger tracer. So the Jaeger client we typically say when we talk about in the context of talking to the backend components, right? So we have the client and the backend, and we use the term tracer typically when we talk about from the perspective of the instrumented application, so your microservices. And then we have on the one agent. So the agent is a component that runs very close to your application and receives data from the tracer. We have a collector receiving data from either the client or the agent, and it stores data into a storage. We have a query or UI, and they're both part of the same binary, even though they're technically separated. And we have an ingester. So the ingester, one of the storage mechanisms for the collector is Kafka. So the collector can write to Kafka, and the ingester then reads a stream from Kafka and writes to the permanent storage. So in terms of features that we have for the future, so right now Jaeger is doing very well the collection part of the things, right? So we leverage open tracing, open census, and open telemetry in the future for the instrumentation part and for the collection part. And then on the back end, we are very good at storing this data on somewhere, right? So in receiving this data, in ingesting this data, and storing that somewhere. This somewhere currently is Elasticsearch and Cassandra for production workloads. But also we support local storage via Badger and in-memory storage as well. The version 1.12 was just merged, was just released, and it includes support for storage plugins. So if Cassandra or Elasticsearch is not your thing, you can write your own plugin and use your own storage. And it uses gRPC plugins or HashiCorp plugins, and basically you write your plugin and respond to a certain API, and Jaeger then asks your plugin to store data or to retrieve some data, and you know how to do that stuff with the storage that you choose. In this way, then Jaeger does not need to maintain a huge set of storage mechanisms. The second big thing that we have is adaptive sampling. So sampling is basically the technique to choose which traces to restore and which traces to drop. Right? So if you have a huge load in your application, you probably do not want to restore all the traces. And then we use this technique called then sampling. So we decide on a sampling strategy. So by default, Jaeger comes with a probabilistic sampling strategy of 1 in 1,000. So there is a chance of 1 in 1,000 that your traces are being sampled, so being stored. But the whole, it would be nice or very good to have the backend define the sampling based on actual usage. Right, so if you have a low traffic application, you probably want to restore everything. And if you have a high load or very critical application, you probably want to restore only a few traces. And those decisions could probably be made by the Jaeger backend. And this is then what we call the adaptive sampling. And then the third big topic is data mining. Right? So as I mentioned, we are very good at collecting the data. But we don't have anything right now to analyze the data that we collected. So if you are interested in this topic of data mining in general, in machine learning, in AI, come talk to us, because we need input, we need feedback, and we need to brainstorm this kind of thing. And that kind of is a good hook to the next topic. So for those of you who've been to the keynote this morning, you've probably seen a slide asking for you to contribute to your communities, right? So if you use Jaeger, we very much welcome your contributions, no matter which kind of contribution you send us. If you're a coder, you can look for the good first issues that we are going to show you right now. But we don't need only coders. We need people who help other people as well. We need documentation help. We need brainstorming help. We meet every couple weeks on Friday afternoons here in Europe, where we discuss not only the problems that we are having right now, but also things that we want for the future. So even if you don't contribute to Jaeger in a more traditional sense, if you have like half an hour to spare on a Friday afternoon, I would really like to see you there on our calls. And then with that, I'm going to show you how to really get started quickly with Jaeger. Our GitHub repo is on the Jaeger tracing organization, and in there we have quite a lot of repositories, right? So we have 22 repositories. For those of you who know Golang, you have a wide variety of options there to choose from. But we also have the UI repo with JavaScript and all this fancy front-end stuff that I don't understand anything about that. We have a Jaeger operator. So operators are also in vogue here. So you probably heard a lot about operators. And we have a cool operator for you to help us shape as well. But also, if you are not a Go developer, you can help with the clients, right? So we have C++ clients, C# clients. We need help with PHP as well, Ruby, Python. Or Java as well, of course. And the best way to start contributing is to enter any of the repos that I've just shown here. Go to the Issues tab and find one labeled Good First Issue. Right? So we have here on the main repo we have 18 such issues. If you need any assistance in getting started, we are on Gitter, we are on a mailing list. You can just pop up there, or even here on GitHub issues, you can just leave a comment on those issues, asking for guidance or asking if the item is still free for you to start contributing. And someone from the team would be more than happy to assist you in your first contribution. So that's what I had for this first part. Now, I know that those introduction sessions, they are quite rich in questions. So I left, so we have about 10 minutes for questions. And yeah, so I'm ready to take your questions now. Yeah.
I think maybe like a newbie kind of question. Thanks for a very good introduction. So I think a popular question is things like logging versus telemetry or traces. So auditing, logging, and traces, like what are really the differences architecturally and when to use when. And I can see things like sampling, when logs becomes mandatory and so forth. Thank you.
I'm not going to find it right now, but there is a very nice Venn diagram that shows when to use which where. I can show you later, basically, because I have to look it up. But basically, so we have those three pillars or three signals of observability, or the three sources of signals. One of them is metrics, and metrics are things that you like. They are aggregatable, so you can count things or you can store things in a histogram. So those are metrics, and that's clear what belongs there. Now, logs, according to this Venn diagram that I have in mind, is logs are events, and those are typically lifecycle event. So your application is starting up, then you record an event on a log file. Traces, they are request scoped. So everything that pertains to individual requests should be part of your tracing signal. And that's typically called a span, right? So a span is similar to one log entry in the sense that it records it's one unit of work or one unit of measurement. And so that's the rule of thumb. So if you are recording something that is request scoped, then I see that as a belonging to tracing. And if it is like lifecycle or related to your application as a whole, then it's logging. Now, just to complement that, I would not use extensive logging inside tracings, right? Because I think it is, if you have too many, if your traffic is too low, is too heavy, then you kind of have too many log entries inside a span, and that's not what tracing solutions were made for, at least not right now. Any other questions? So I have stickers for the best questions. Yeah.
Hi, thank you for the talk. For sampling, how do you make sure that it is representative of the load that is hitting your services?
What is the second part? If the tracing is the sampling is representative of the load.
Yeah, basically, if you take just 1 in 1,000 requests, if I want to investigate a specific problem, maybe the issue is in the rest of the requests, it's not in that specific.
Right.
Yeah.
That should come also with part of, so this all belongs to sampling in general, right? And how that is implemented, then it kind of is different. We have so you can implement your own sampling strategy, and you can create the strategy saying that if it is about this endpoint here, then I want to record all the time. If it is not about this endpoint, then I want to record like 1,000 or so. So you can do that by extending or by specifying your own sampling strategy. I might be wrong here, but I believe that the sampling strategy that we support already, so I know for sure that we support loading as a JSON. Your strategy is based on service names, and I think operation names as well. So you can say that for all the spans that are named following this pattern here, I want to follow this strategy. So I think it is already supported out of the box, but I'm not quite sure about the operation name part. I'm sure about the service part.
Thank you.
Hi. So just to get that right, the sampling strategy is configurable,
yeah,
but not at runtime at the moment.
You can change, right, yes. So we don't have the adaptive part, but it is you can configure it per service, per operation, question mark, right? Yeah. And then there was a question here.
Hello, my question is about the topology of the calls. Your framework can trace the HTTP synchronous calls. Is it able to trace the asynchronous calls using Kafka as the middleware? Yes.
Yeah. So that belongs to the instrumentation part. That's kind of outside of Jaeger, so that belongs more into to open tracing or open census and open telemetry in the future. But yes, the main idea there. So there is this notion of context propagation, right? So you create a context somewhere, and you serialize that context and send. So in the case of Kafka, we could send the span context as part of the metadata of the message or of the Kafka item. Yeah. So you send that, and then whoever consumes that information then deserialize the metadata, deserialize the span context, and then whenever it creates new spans, it says, I belong to the trace ID XYZ.
As you say, always there is HTTP tracing. Can you also trace some lower level protocols like TCP, UDP, like for the next QUIC or something like this?
Yeah, there is a lot of talk about that, like integrating application level tracing with things like K-trace and S-trace and P-trace and things like that, so more to this level. I think it might be possible. I don't think it might be desirable. It might be, it might not be. I don't have an answer if it is. But the thing is, so it could work. So the thing is, I believe that the target consumers of this information are different people. Right, so when we talk about application level tracing, we're talking mostly about developers or DevOps looking into business reasons of why things are failing or application reasons. We do see network latency as well, which is quite useful. But then when you go down to that level, or when you want to see more information about that, then it requires an expertise, which is typically held by other teams.
A question about what you see of multi-tenancy options out there.
Okay.
We have implemented one where we have Jaeger instances that are fronted with kind of an OAuth-based, an LDAP-based authentication proxy, and then we share the same Cassandra database underneath with a lot of individual key spaces, I think they're called, right? So to kind of keep traces individually separated. What other multi-tenancy or managed service Jaeger options do you see out there?
So we have a blog post on multi-tenancy, or what are all the options for multi-tenancy when it comes to Jaeger. But I'm not sure if it's not here on the front page. But it is our Medium blog publication, and you can just look at the archives. But basically, tenancy is something that means different things for different people, and we have a constant discussion or an open topic around multi-tenancy for I think 2 years now. Mainly because you can achieve already multi-tenancy, just like you mentioned, by having different instances talking to different key spaces in the back, and this is certainly the most popular way of doing tenancy. But that's one way of seeing tenancy, right? So this is on tenancy at the data level, but then we have tenancy on authorization as well. So probably I do want people to have access to traces belonging to 2 different tenants. Or I have requirements like I'm in the healthcare industry, then I have requirements to have data strictly split from tenants, between tenants. So it is possible to do quite a lot of scenarios playing with how you deploy Jaeger. And Jaeger is very lightweight. So Jaeger itself the all-in-one binary is 30 megabytes or something like that. So it's really lightweight. So it is not very costly to deploy a lot of Jaeger instances on your infra. Of course, it costs to maintain those instances. But the costs in terms of RAM or resources, network resources and so on, they're not very different. Does that answer the question? Okay. Okay, so we have now then a short break. For those of you who want to stay for the deep dive session, I appreciate. For those of you who've had enough of Jaeger, I expect to see you on the community sometime. Thank you. Right, so I'm very glad that you are still here. This is now the deep dive session. Do we have people here who were not during the intro session? Can you raise your hands if you were not here for the intro session? Okay. So for you, so you know me, but for the other guys there, I'm not Prithvi. Hello. Prithvi could not join us, so he's not delivering the deep dive session. I'm here on his behalf. I'm Juraci Paixão Kröhling. I'm a software engineer at Red Hat, but I'm here today as a maintainer on the Jaeger project. So for the majority of you who were here during the intro session, you've seen a slide just like this before, where I listed all the components that are part of Jaeger. But I'm personally very bad when I see these kind of lists and I don't see how things move. So I try to come up with a flow diagram. And this flow diagram is kind of shows how Jaeger might be deployed, but it's not 100% accurate on that term, on that aspect. It only shows the components that we had on the previous slide. Right? So we have our application. In the example from the previous session, it is the Quarkus application. And as part of that application, we embed a tracer, a client, all right, as a library to our application. Now, for a Java application, it might be the client might be in the same WAR file, it might be in the same ER file, it might be in the same jar file. For a Go application, it belongs to the same binary. And for other languages, it's very similar, right? So it belongs to the package of your application. That's the client. The client is the component that knows the how to record things. So you use OpenTracing, OpenTelemetry, OpenSynthesis to tell the what to record, and the client knows the how to record things. Typically, when you don't specify otherwise, the client will just create this data, create those spans, pack them into batches, and send this ball of spans over the wall, and expects something on the other side of the wall to catch all those spans. And that something on the other side of the wall is the agent, right? The analogy here is because the client sends data via UDP, and UDP, we don't have any guarantees, right? So we just fire and forget requests, so packets, to a specific port, and if there is nothing on that port listening to that, it will just get lost. Or if the other side, or if anything happens to the connection, data is just lost. Now, because the agent is typically on localhost, we don't have much of those UDP reliability issues, right? So it works quite well here. Now, the point is then that the agent runs on the same machine, reducing the load on the application itself, and then the agent is responsible for sending this data to the backend, to the collector, in a more reliable way via TCP, perhaps using HTTP on top of TCP, of course, or maybe gRPC or Thrift, or so how it actually sends it doesn't matter, but it's in a more reliable way. And then from the collector, we store data into permanent storage. So Cassandra, Elasticsearch, or some more ephemeral, so in memory, or perhaps local storage via Badger, or even something new that you write yourself using storage plugins. And then once data is on the storage, our query component retrieves data from the storage, typically on behalf of the UI. So the UI calls the query, and the query gets things from the storage. And then there is an alternative path, which is up there, up there. We have then a Kafka setup, or a Kafka cluster, where then the collector, instead of writing to storage, it writes to Kafka. And then ingester, which is a new component, reads a stream from Kafka, and then it stores data into the storage. The whole point here being that we remove pressure, or we make the connection between collector and storage we make it more elastic, right? So we are able to absorb more pressure. Now, a little bit more details about each of those components. So the tracer, typically, so we have tracers for most of the major languages, right? So Java, C++, C#, Go. We have tracers or clients for other languages as well. We have community-supported tracers. And what they all have in common is that they support or they implement the open tracing specification and APIs or interfaces. So there's no Jaeger API, so to speak. right? So your application is only talking open tracing. And when you plug the Jaeger tracer, it's able to use your open tracing instrumentation to create data based on that. And then there's, of course, the ability to use other tracers like OpenCensus and in the future, again, OpenTelemetry. But that technically does not belong to the tracer component. Now, the agent, as I mentioned, is a component running local to your application, and it acts like a bridge, right, between your application and the collector. The agent, so localhost, what is actually then localhost nowadays? Right, so if you're running on bare metal, that's clear, that's your bare metal. But if you're running on Kubernetes, then what is your localhost? Is it your pod? Is it your node? And you decide where to run the agent, as long as it's on the same, on localhost or very close to your application. Because remember, the whole purpose of the agent is to receive data via UDP. So it has to be somewhere where UDP is reliable. Right? So in Kubernetes, it's typically the same pod. So it's a sidecar to your pod application. And that works very well. Now, for the cases where you have thousands of pods, that means you have thousands of agents. And even though the agent itself is very small, I think it is close to 15 or 20 megabytes in size of the binary, it might still be, if you have thousands of pods, then it's too much, and then you may want to use daemon sets instead. And then on the collector side, so the collector is a component that receives data from the agent by default, but the clients can also talk directly to the collector. So I can configure my client to use a TCP connection to the collector instead of UDP to the agent. The whole purpose of the collector is to receive data. It then cleans up the data a little bit, do some processing with the timings, right? Because distributed systems, we cannot always rely on the clocks being in sync. And the collector is the right place for us to do some clock skew, right? So we adjust the timing based on information that we know. Basically, a span that was reported as a child of another span cannot have started before such span, right? So we do such logic belongs then to the collector. But the main goal of the collector is to write things to storage. So it receives data in a different range of formats. So it accepts data in Jaeger format, a Jaeger proprietary format, or in Zipkin format. And in the future, if we have such a standard for this kind of data, we just add a new endpoint to the collector. And then the second main goal is to write those things to a permanent place. And then we have an ingester. So the ingester is a relatively new component, and it reads basically data from Kafka. So the collector, one of the backend storages for the collector is Kafka, right there. The ingester just reads the stream from Kafka. We have the query. So the query component provides some REST endpoints. Now, those REST endpoints are not documented or not well documented yet, and they are not part of the public API. But we do intend to build an API for you to interact with Jaeger, with a Jaeger query, so that you can build your own analysis tools and you can retrieve spans that you care about. Perhaps you are also listening to the streams from Kafka and storing data somewhere, so you know the trace ID, so you could get the trace from Jaeger based on such ID. Yeah, so basically it reads from the backing storage. Now backing storage might also be your own storage plugin, so we call your storage plugin via gRPC, which is asking for data, and you return data to Jaeger. And finally, the UI. So the UI gets data directly from the query, right? So the main consumer of the query is the UI, and we have features that we've seen on the previous session here. So we can list traces, we view traces, we have different types of views, the timeline view, we have the graph view. We can do comparison of traces, and we have a very basic service graph. Now, those are quite a lot of components, right? And it's probably complex to deploy and manage all of that. But as I mentioned at the very beginning at the slide with the flowchart, that does not necessarily represent how we deploy Jaeger. So we can deploy all of those components into one single binary. So we have one binary called all-in-one, and you just download that binary and you just run that binary. It contains pretty much everything, right? It does not have the ingester or the client tracer because the client tracer belongs to your application. And the ingester is not part of the all-in-one, but pretty much everything else is there. So you can just Docker run, just like we did on the demo, Docker run in one specific image, and it's there. Now, when you move to production, though, you probably want to at least split the query from the collector, because the collector has to be really high available and highly scalable. And the UI or the query is probably a low traffic application, so it can be on its own pod with, I don't know, one replica, whereas the collector probably should be distributed with a lot of replicas. But how you actually deploy that, how you install these components, also depends on your infra. So you can either deploy in a very traditional sense with bare metal, or on bare metal, and then you manage that with systemd files or whatever process monitoring tool or process management tool that you choose. Again, you specify which components to run, or you can install Jaeger via Helm. So there's a Helm chart for Jaeger. You can just specify the chart values and you install the chart, and you have a new Jaeger running there. A newer option for installing Jaeger is via the Jaeger operator. So you can install the Jaeger operator via Helm as well, and then you can install individual instances of Jaeger via the operator. So you create a CR, a custom resource, just like any other Kubernetes object, saying I want a Jaeger, I want with the strategy production, and my Elasticsearch is here. And then you pass that to Kubernetes, and the operator picks up this new CR and builds a new deployment for you, a new instance of Jaeger for you with all the right components, on the right sizes, on the right places. Jaeger can be tweaked or configured we have a lot of options there, and it's pretty much impossible to add all those options in only a couple of slides. So what I have here to tell you is for every component, we have a help option as well. So with the binary or the Docker image, you just pass the -- help option. You have a list, a complete list of configuration options, and hopefully each one of those have meaningful descriptions. But if not, then open an issue for this. But it should be so the description should be quite easy to, should be quite descriptive. Each one of those options can also be specified as an environment variable following the typical cloud native applications. But if you prefer configuration files, you can specify a YAML file or a toml file with all the options and pass to the components. Now, if you're using the operator, then you probably are going to configure the instance using the CR. Right? So inside the CR, you specify that my Elasticsearch is in this place here, and the operator then takes care of creating the right way of specifying that option to the underlying Jaeger component. Yeah. Now, Jaeger also, if you installed Jaeger in your Kubernetes or in your bare metal, be it using all-in-one, be it using individual production, individual components, you still need to monitor that, right? You probably don't want to just install Jaeger, but you also want to monitor it. Each component has its own /metrics endpoint. And by default, it outputs Prometheus metrics. Now, the beauty of operators is that we can tie everything together. So if there is a Prometheus operator running on the same cluster, the Jaeger operator will just add the proper annotations to the components, and the Prometheus operator is able to auto-discover the Jaeger components. Right? So you don't have to do anything if you have both operators running. They just find each other and metrics just flow to Prometheus. Now, if Prometheus is not your thing, we still expose all those metrics using xvar. We have quite a lot of options there. Pretty much everything that we have as an internal state, we store as a gauge or as metrics or histograms. So it is quite, perhaps not easy, but it's quite, whatever you want to measure from Jaeger, you can probably measure using the metrics that we have already. So you can measure how many spans we received, how many traces we received, and we have that information also per service, so you can monitor individual traces for individual services. Yeah, and then performance tuning. So how many of you are using Jaeger already? Okay, that's a good number. Okay. And how many of you have heard about dropped spans or spans being dropped? How many of you have faced this issue? Yeah, one here?
It's expected with the buffering and UDP as well.
Was that?
Like, it is expected, I guess.
Well, sort of, yes. So the thing is, Jaeger was designed to be very resilient, meaning you should not be able to break Jaeger. Jaeger should not crash because you are sending too much data to it. Right? So if you are sending thousands of spans per second, Jaeger will then, and if Jaeger is not able to consume that or to ingest all this data, Jaeger will start dropping spans because it is desirable to not record things that we may have already similar data from the past or we are going to have in the future. So we just drop data instead of crashing the VM or instead of having a OM killer process from Kubernetes just killing our pod. Now the thing is, it is not the best default that we have there because it is very conservative. Meaning, if you have a machine with, I don't know, 10 gigabytes of RAM and you just run the Jaeger all-in-one, for instance, then even with moderate load, you are having dropped spans because the queue size is small. So we store everything in queues inside Jaeger, and for each one of those queues, we have workers, and we pick items from this queue. Each worker picks items from the queues and process those items. So in case of the collector, each worker is responsible for storing data on the storage. So if the queue size is not big enough, then data is being dropped, even though you have more than enough memory for that. It is very hard to come up with a reasonable default. We have one GitHub issue where we intend to automatically adjust the size of those queues based on information that we are able to gather over time. So if we know that spans are on average of, I don't know, 2K, and we are allocated 2 gigabytes, then we are able to come up with reasonable queue sizes. That's not there yet. Before this feature is implemented, I recommend you taking a look at the performance tuning guide, and that provides a nice rule of thumb values for depending, or how to come up with those numbers for specific scenarios. And then we have, again, this similar call to action to the previous presentation. I cannot emphasize that enough, that we need your help. We need, I mean, some of you raised your hands when I asked if you're using Jaeger. So we especially need you to tell us how you are using Jaeger. What is Jaeger missing for you? What do you want from us? And perhaps even better if you can publish a blog post specifying how you're using Jaeger. Right? Again, we have bi-weekly meetings, so join us and talk to us, and even if only to brainstorm. And I'm not showing how to find good issues again, because most of you know how to do that. But basically, on our GitHub repositories, all of them we have issues labeled with good first issue. That's what I had for the deep dive. Now, similar to that one, typically we have good questions here at the end, so I saved a good chunk of time for your questions. Yeah.
Thank you very much for your presentation. I was wondering, with the dropped spans, is that also being recorded in a way that you know that the whole trace is then broken?
Yes.
Okay.
Yeah. So, so the way that sampling works, sampling is made at the first span, so at the root span. But if there is any other span that was dropped after that, then that span is not going to show up in the UI. Now, if that is the root span, so if it is the first span that we generated for a specific trace, then you see a specific message on the UI saying like, so people who faced the dropped spans problem probably knows this trace without parent ID bug, right? But it's not really a bug, it's just that the parent span was dropped. So yeah, you have a missing span in your trace.
Okay, thanks.
Here. Oh, unless you have a... Yeah.
Simple question from me. Does Jaeger support automatically HTTP?
Automatic?
Does Jaeger support automatic HTTP injection, where the request ID for incoming request from browser can be traced in the UI?
If I understood the question correctly, so you're asking if Jaeger supports making the connection between incoming and outgoing HTTP requests automatically. Is that it?
Yeah.
Okay,
yeah.
And that is a instrumentation problem, and that is solved by open tracing or open telemetry. But Jaeger, I mean, so the tricky, so the thing is, the tracing or the instrumentation part, it calls the tracer to inject the context into the payload. And Jaeger does provide all the interfaces to both inject and extract the context from the payload.
Okay, so is that possible that this injection will fail because when the
I see.
Because sometimes when the HTTP header is injected, then load balancer or any other external control could drop that header.
So if the load balancer is removing the context span or the context header, then there is nothing we can do. Then we're going to start a new trace, probably. Right, so you end up having multiple, because I mean, the decision to create a new trace or not is whether we have a span context or not. And the context comes typically with HTTP request or inside a message. And if we cannot find a context there, then we just start a new trace. So you may end up having multiple traces for the same business transaction.
So it's fragmented. Okay, thank you.
Yeah.
I think, I mean, I had the expectation just like by looking at your explanation on the drop packages because of a couple of things, and I'm sharing my view so that I can hear your comment as well, which is there is a buffering. You said like the spans are sent in batches. So anytime the pods are recycled or the application crashed for some reason or restarted non-cleanly, then you would be losing some spans. Yeah. And the same was UDP. I mean, I think UDP, if it's localhost with the pod, that is very minimal. But I mean, if it's a daemon set with a lot of pods, then there can be a way sometimes that you can mess a packet or two, right?
Yeah, so technically for daemon set, they're on the same host. So unless there is a problem with the software networking level, then But I mean, so typically UDP is not reliable over real network, right? Over the cables. In that case, that's why it is good to have on the same physical host at least. But yeah, you're right. I mean, if data is dropped somewhere, then we don't have a reference for that. There are some use cases for requiring data that is recorded to be stored. That's not typically how tracing has been seen. Because most of the traces, when you stop to look at them, most of the traces and most of the spans actually, or I mean, similar spans, they're the same, right? And they may be different in a few milliseconds here, a few milliseconds there. But if you compare most traces for the single business for one business transaction, they're pretty much the same. So the idea of dropping spans is that it's okay if you drop one of those traces because it is similar to other 50 that happened at the same time.
And I think the conclusion then was traces is like maybe relevant to our earlier discussion and my earlier question. We should not be expecting them to be 100% and 100% all the time. We cannot, I mean, guarantee that. But we do, or maybe we do want to this to happen as well. Yeah. But also, it cannot be used for things like auditing or stuff where you really need to keep track of every request that was received, right?
Yeah, there are two sides to that. One is right now, you absolutely should not rely on all the data being there, but it should be your goal when configuring Jaeger to store everything. So when you configure Jaeger, you should provision Jaeger, you should configure it so that it's able to accept and consume all the data that you report. Right? So if you're dropping spans, it's a sign that you should be doing something about that. If you're constantly dropping spans, then you should either change the configuration or change the size of your machine and things like that. Okay. So I would not say that it's expected to have spans being dropped, but it's not, I mean, it is a symptom of something, right? So you should take care of that, but you don't have to, wake up at 2 a.m. because of some dropped spans. The other side of the question is on use cases where you need all this data there. So there are some use cases that we could probably be fulfilling with traces, but for that we need guaranteed delivery, so all the data that is generated has been reported and stored, and things like that, and we don't have that yet.
Yeah. And the last question for me is, you said the collector does that adjust times or like real times in a way? So how this is happening?
It is very simple logic. And basically, it's what I mentioned, right? So if we have two spans, one as a child of the other, and this one here is on timing information there, we say that it has started before the parent, then we adjust that to be like here. So that's pretty much all we do.
But I mean, we don't know which references.
Yeah, we just guess. Yeah. There was another question, yeah?
Yeah, maybe it's just a little bit of a comment on the differences between the UDP protocol and the HTTP protocol. If anybody is trying to kind of run Jaeger as a managed service and you want to have it externally exposed on the collector side, the only protocol that's kind of easy to add authentication upon that you can also utilize from some of the standard open tracing based libraries, that's HTTP, right? Yeah. So you can inject authentication, authorization, headers into the HTTP protocol, but that's not something you can do on the UDP part or on the backside of the agent. So anybody looking at, running it with authentication on the collector side, it should explore, just add a proxy in front of on the collector with some kind of, authentication credentials to, an OAuth bearer token or, a classical HTTP authorization header.
Yeah. So that's pretty much accurate. One extra thing I would add is we just, like a couple months ago, or even less than that, we had a support for the gRPC connection between the agent and the collector, and we can now do also authentication in between. In theory, I have not tried, but we can use the same approach there. So we should be able to place proxies to do authentication between agent and collector.
So I would be also interested, since we heard in the keynotes already about this, the future. So where is it going? So how can we then in the future correlate this stuff. So, for example, usually if I see a service degrading, I already see it in the metrics that I get from the proxies that I have deployed with my services. So, how can I then get this all together?
So tracing is very good to look into things that failed, to look at very specific requests that failed. So if you know that business transaction failed, or if you know the time range, and then you see like one trace with a exclamation mark, then you open that one, and then you see the whole transaction, and you see why things failed. So that's like the second step in the root cause analysis. The first step is seeing that something's wrong on a dashboard. And the whole idea there, and I think that's what most people are doing nowadays when they provide tracing solutions, is you zoom into that time range, and from that you see the logs and you see the traces. During the keynote, he was talking about linking log entries to traces. That kind of requires the context to be available for logs as well, right? So when you create a new span, or when you log something, if there is a span opened around this log statement, then it adds the trace ID or the span ID to the log entry. And only with that you can link to individual.
So then it would be, of course, nice to have this triggering that these spans don't get dropped at all costs.
Right,
so,
yeah.
So, for example, if your metrics reach a certain threshold, then you ensure that this service, for example, traces all the requests.
Yeah, there is one hard problem in tracing, and that is knowing when to sample things and be 100% accurate. Right, so we do not want to record, or it is not desirable to record two same spans or two same traces if everything's fine. I mean, we are just going to delete them. And the hard problem there is determining after the fact what we store and what we don't store. And that's called then the tail-based sampling, right? So we decide to sample not at the head of the trace, but at the tail, right? Now, this is a hard problem because as you can imagine, on microservices, we may have one service running on one node, another service running on another node, and they don't talk to each other about tracing. What they do is service A sends data to Jaeger, service B sends data to Jaeger, and Jaeger then stitches all those things together on the UI. So if things fail there on the service B, that service B has to tell service A not to, or to trace, or not to sample, or not to sample that. Now, while that might sound simple for two services, when you have like hundreds of services as part of one transaction, it becomes very complicated. So there are kind of a couple of solutions, but no real solution right now. Yeah, right, yes. And then you just roll, you just do rolling of the logs and drop logs, and yeah. Yeah.
So if I run some container or something in a pod, can a Jaeger automatically attach labels, pod labels to each span?
Yes, and it does. Okay. It does. So Jaeger attaches logs with attaches labels with the host name and with the IP name by default, and also the sampling strategy that was used for that trace. Yeah, it does not by default, but it might. There is, so depending on the client that you use, so if you use the Jaeger, the Java client, you can specify an environment variable called Jaeger_tags. And those are static labels to add to all the spans for that application. And then you can use I think it's called the upward API or something like that from Kubernetes, to say, well, for inside that environment variable, I want to store the pod name as well. But the pod name is kind of moot because it is the container name and it is the host name. So it is recorded already, right? So the host name on that span already reflects the pod name. But you can use that API to specify other information from the node. No. Well, not automatically. especially because Jaeger was not meant to run only on Kubernetes. But it's something that, I would encourage you to open an issue on the Jaeger project and discuss that, because I think we should be able to be smart enough to determine whether we are running on Kubernetes. And if we are running there, then we can probably get those tags from Kubernetes. Even if the Jaeger client is not doing that, we can probably do that with the Jaeger operator. So when the Jaeger operator sees your application, it can probably change the Jaeger tags environment variable to include this information. Open an issue for us. Let's discuss that. This one there.
Yeah, it was on the question of what to do, how to decide when to do a trace if there's an error that you need to debug. I mean, if you're on an HTTP protocol, you can kind of inject in the header from the outside. You need to be able to control your client that is initiating your request, but you can inject that you want to have a forced tracing started. If you have a low sample rate and you want to make sure to actually make a trace on that, you can kind of tell as the client that you would like to have a forced tracing started, which could be helpful sometimes if you can control your client. Yeah.
We have a question on the other side, so this side of the room dominated. Now we are ready for the next side.
Surely good tracing comes for a price on resources I need. Is there any assumption I can take on how much more capacity I need in my Kubernetes cluster if I enable tracing for simply everything?
I'm very glad that we finally had the performance question. It took, I don't know, 40 minutes to get this question. She's not here, but we had a talk yesterday on that specific topic. So the talk was, what is the performance overhead of tracing? And this was the subject of Gabriela's internship, so the person who delivered the talk yesterday. And basically the outcome is instrumentation itself is not costing you anything. So, instrumenting your application the costs are is not very high, or there are not any costs at all, actually. Because in most applications, like in Java, it is that code and the JVM would just remove that. Now, in terms of when you plug a concrete tracer like Jaeger's, then of course you are doing something, then you are paying something. So when for in-process tracing, like when you have one HTTP request, then you have all the database calls, and you are instrumenting all the database calls, then the collection of that kind of data is potentially costing you around 15% of throughput. Right? So when you provision things, then you should provision probably with a 1 or 2 nodes more for tracing. I mean, 1 or 2 nodes more, it's really relative. But I think 15% is not a high price to pay for this kind of observability. And then when you do communicate over the network communication, one service to another service, and you're measuring how long that communication is taking, then the costs are very low, and your network connection itself costs you far more than observing that connection. So you don't need any extra resources for that. Okay, so I guess that's pretty much it. Thank you very much for attending, and once again, join us.